Hi, I'm Amy Roberts. I'm an assistant professor of physics at CU Denver, and I am a PI in the Super Cryogenic Dark Matter Search collaboration. And this is a collaboration that is working on detecting dark matter, which is our way to name a mystery of how our galaxies and how our universe is bound together. Okay, so I'd like to say a little bit about the software environment that my dark matter collaboration works in. So we've recently moved, and by recently I mean in the last several years, we've moved to a centrally controlled web-based analysis environment. If you've used Jupyter notebooks, you'll probably recognize this as Jupyter Lab, and this has really improved our science efforts. And so I'm not exaggerating when I say that in the old days, when we expected everyone to install their own copy of the software, it could take up to 2 years for students to make their first plot. And this is graduate students. It typically wasn't possible for undergraduate students to work on any kind of data analysis within our collaboration because of that long startup time. So we had a couple goals when moving to this system, and in general, we were really successful with these. So we did really improve the time to analysis. We've really increased undergraduate participation. We're still dealing with things like stability and exactly what kind of software we'll provide in that environment. But in general, this has really worked well. And so the ongoing question that we sort of face is how to fund this kind of analysis infrastructure and fund work on it. And the solution for us has involved a myriad of things, but one of the really critical things has been Exceed and Open Storage Network and gateway support. Okay, so let me show you sort of what this looks like. So what we have down here are sort of the underlying technologies that make this possible. So we have grant funding for our project specifically, but this sort of online analysis environment and accessible analysis environment really would not have been possible without things like the Open Storage Network. It gives us terabytes of free storage. In particular, a notable thing about the storage is that it's much more accessible than other storage sites that we've had for our data in the past, which have always required accounts and typically additional authentication. Then also we have the Science Gateways support and support through Exceed. So there's allocations from all of these, the Open Storage Network, SGCI, and Exceed, that make this possible. And then we have these Jupyter Hub clusters that sort of run on top of different sites within the collaboration, and then that all supports our analysts. And what we're hoping is that that's eventually also going to support workshop participants and students in classes. But even for now, this support for Super CDMS analysts we've really increased the number of analysts that we're supporting and also the number of undergraduate analysts in that group. Okay, so what I just talked about was the Open Storage Network as part of the infrastructure that supports data analysis within our Super CDMS experiment. So that's one single dark matter experiment. What's becoming clear is that we need a way to combine efforts in the dark matter field and analyze data across different experiments. And right now, that's really not possible. And so myself and Matt Turk, a professor at UIUC, put together a proposal for something that we're calling POND, Personal Data Delivery. And so the idea is that this is a data analysis and data delivery infrastructure that lets collaborations with terabyte scale data easily get and share access and analysis of their data. And so this is something that's really new in the community because dark matter experiments are relatively small, and by small I mean on the scale of 50 to several hundred collaborators, that means that we don't usually have resources, well actually we never have resources to invest in making our data accessible to people outside of our collaboration, and so it's just not. And so this kind of analysis infrastructure that will allow us to analyze data across different experiments really wouldn't be possible, and in particular really hasn't been possible. And in particular, it really wouldn't be possible without the Open Storage Network, because again, the Open Storage Network is providing us that large scale data storage that is more accessible than traditional places where the dark matter community stores our data. So we typically store our data at sites like national labs, local HPC clusters. All of these have their own requirements for accounts and authentication. And sometimes that data is accessible. For example, in Super CDMS, our data is actually downloadable by anyone who has the web URLs, but we don't share those because our primary method of security is people don't know about it. And that works well, but it doesn't work well if what you want to start doing is working with outside collaborators and allowing them access to specific parts of your data. We have no way to authenticate for only specific parts of our data. So the open storage network is really valuable. We would not be able to ourselves put data that could be analyzed by people outside of our collaboration, and other dark matter collaborations, they also don't have the infrastructure for this. So this is really critical. The final thing I want to mention here is that the initial use of this will not only be the dark matter community, it will also be the computational astrophysics community. That's another community that has this terabyte scale data, but again, the collaborations are small enough that being able to make their data accessible in a controlled way beyond their collaboration is not feasible with the resources that they have. So the Open Storage Network is providing this really significant service for us, and sort of allowing us to take a look at this new science questions. Uh, okay, so I've talked about how the Super CDMS experiment itself uses the Open Storage Network, how we're hoping to use the Open Storage Network to enable cross experiment analyses using this new infrastructure that we're building, Pond. What I want to bring up is the possibility of using the Open Storage Network as a standalone solution for communities that have smaller data sets. So I am an experimental nuclear physicist by training. The data sets in the nuclear physics community typically range from megabytes to hundreds of gigabytes, and sometimes up to a terabyte or two, but typically in this megabyte to hundreds of gigabyte range. And for these communities, a lot of times they don't need the more advanced infrastructure that we're trying to provide with Pond. Um, they kind of just need to be able to put their data in a shareable location where they have some permission controls, and maybe store a little bit of metadata with that data. And so what we're exploring is using the metadata feature that we can, with the open storage network, we can store metadata along with the actual file objects. And what we're looking at doing is using that metadata information as sort of a basic data catalog that could be used within these communities for sharing and accessing data that's of interest.